Hello guys, how are you? This is a regular face that you are used to this AMG. Now we are going to consider another topic that we have listed from our previous videos. If you can remember, we listed out several topics, of which today we're going to cover one, and that is trigonometry in maths. What we are interested is in trigonometry. That's what we're interested today. Now, in trigonometry, we will be concerned with the relationship between angles and the side lines of triangles. That's what we will be interested in. The relationship between angles and the side lines of triangles. That's what we'll be interested in. Now, before we dive into details, let me go through some concepts that we are used to in our daily lives. Now, if we consider a straight line where we assume that one of the edge here is fixed, if it's fixed, and if you allow this line to move round, if you allow this line, this is the origin, the starting point. Now, if you allow this line to move round, if you sweep it round, it will go back to its starting point. You see that it has traced out a circle. It has traced out a circle. It has traced out a circle. Assuming here is fixed, then swing it this way. You see that it has traced out a circle. Now, conventionally, we are saying that this line that has moved this way, once it moves from its origin, its starting point, we are saying that it has subtended some angles. It has subtended some angles. Now, we can measure angles in terms of degrees or radians. We can measure angles in terms of degrees or in terms of radians. But conventionally, we have it that if this straight line comes back to its original point, I will say that it has subtended an angle of 360 degrees. 360 degrees. If it moves from its starting point, move back to this point, that's a complete revolution. If it has made a complete trip back to its point, then we are saying that it has subtended 360. Then if that's true, then if it starts here and it comes to this place, half of it, it will be 100. That means it has subtended 180 degrees. It has subtended 180 degrees. That's true. Then if we're interested in just maybe half of this one again, if it moves half of this one again, assuming here is the center, and if it moves half of it, then here will be 90 degrees. Here will be 90 degrees. If it moves half of this one again, here will be 45 degrees, and so on. So a complete revolution, movement from here back to its starting point, we're saying that it has subtended an angle of 360 degrees. Now, in our homes, we are used to the movement of clock also. Those of you that have got clocks in your houses, you can see that we have clocks that also move in this direction. You know, in making a complete trip, but in clock we don't talk about it and we don't measure it in degrees. We measure the clocks in terms of minutes and seconds. In terms of minutes and seconds. So if for clock, if it moves back to this place, you can talk about it in terms of 60 minutes, or you talk about it in terms of 60 seconds. Now let's consider something here. Let's consider something here. If we are interested in this second. Dividing it this way, we said is 180. If we divide it this way, meaning that here will be 90, here will be 90, here will be 90, here will be 90, making 360 degrees. Now, a movement from here to here, in terms of degrees, we have 90 degrees. Now, in terms of, you can also talk about it in terms of 1. Now, this part is 1/4 of the entire circle. From here, the combination of these two will be half. Okay? So, you can also talk about it in terms of minutes. From here to here is 15 minutes. 15 minutes. 15 minutes. And also, you can also talk about it in terms of 1 all over 4. 1 all over 4. The movement from here to here. Now, if we move to this point, you will see that in terms of angle, we are talking about 180 degrees. Now, in terms of minutes, we say this is 30 minutes. Then, in terms of 1, then we are saying that it has moved half, which is 2 over 4. The same thing as 1 all over 2. 1 all over 2. Now, if it comes here, we have, in terms of degree, we have plus another 90 will give us 270 degrees. That's what we have, 270 degrees. In terms of minutes, we have 45 minutes. 45 minutes. In terms of minutes, we have 45 minutes. Then in terms of 1, we have 3 all over 4. 3 all over 4. That is 0.75. 0.75. Now, if it comes back to this space, then we have, in terms of degree, we have 360 degrees. Then in terms of minutes, we are saying that we have 60 minutes. Then in terms of 1 here, we have 1 degree. We have 1 degree. 1 degree. So this is the relationship that we have. So you can see that we can talk about this in terms of degree minutes. Degree minutes at this point. If we're talking about minutes, we can also talk about in terms of seconds as well. Now, what we're trying to establish is that 1 degree here, that is, if you bisect, if you divide this thing, this is 360 degrees, if you divide this thing into 360 places, that is, we are talking about 1 all over 360. Okay? 1 of it is 1 on the 1 all over 360. That's what you have. Now, that 1 that you have, we are saying that is equivalent to 60 minutes. This one is equivalent to 60 minutes. It's equivalent to 60 minutes. Then 1 minute is also equivalent to 60 seconds. 1 minute is equivalent to 60 seconds. Then if that is true, then you can also talk about these seconds in terms of degree. In terms of degree, that is this by this, so that you have 1 degree is equivalent to 60 minutes, which is also equivalent to 3,600 seconds, which is equivalent to 3,600 seconds. That's what we have. So this is a relationship between degree, minutes, and seconds. Now, if having said this, we can then talk about, we can convert things that are in degree, minutes, and seconds to decimal degrees. We can convert things that are in degree, minutes, and seconds to decimal degrees. Now let's consider an example. Let's consider an example. If we say convert 45 degrees, 36 seconds, 36 minutes, then 18 seconds to decimal degrees. To decimal to decimal degrees. This we can do. This we can do. Now, already this side is in terms of degrees, expressed in terms of degrees. This side is in minutes, this one is in seconds. So all that we need to do is to convert this one that is in minutes and seconds to decimal degrees. This we can do. Now, concentrating on this side, already we have it that 1 degree is equal to 60 minutes. So 36 minutes will be 36 minutes will be 36 times 1 degree all over 60. Okay? Of which this one is one will not perturb anything, but based on this relation, if you do this, this and this is off, this and this is off, then you will be left with 36 all over 60 all degrees. And if you simplify this, you are going to have, if you simplify that, you are going to have 0.6 degrees. You are going to have 0.6 degrees. So first of all, we have 45 degrees now plus 0.6 degrees for that of the 36 minutes. Now for this other one, for this 18 seconds, it's the same thing. There is a relationship that in 1 degree we have 10,600 seconds. In 1 degree we have how many? 3,600 seconds. Now if that's true, then 18 seconds will be 1 degree all over 360 seconds. So this and this is off the job market so that you will be left with 18 all over 360 all into degrees. And this will boil down to 0.005 degrees. That's what you have, 0.005 degrees. So if you add this remaining part, already we have 45 degrees before. This one we have converted to degrees. This one in second, if we convert 18 to the second, we are having 0.005 degrees. So if you add all this, what are we going to have? We are going to have 45 degrees point, if you add all this one, you are going to have 0.605 degrees. This one, all degrees. That's what we are going to have. Already this one from the question is established. All that we did was to convert this one in minutes and seconds to decimal degrees. That's what we have. In like manner, we can also try maybe another example, or this we can also maybe do later at home. The viewers can also try this to test your level of understanding. So if we say convert 53 degrees, 29 minutes, 7 seconds to decimal degrees. This you can also do. Always remember that 1 degree is equivalent to 60 minutes, which is also the same thing as 3,600 seconds. So with this relationship, you will be able to convert this one into decimal degrees. Now, having said all this, let's quickly go to radians. Let's quickly go to radians. Let's quickly go to radians. Already, we have talked about that of degrees. We've said we can measure angles in terms of radians and degrees. Now, for that of radians, we are saying that if we consider this as a circle assuming that here is the center, okay? Assuming that here is the center. Now, if this is the starting point and we move this line, we try to sweep it as we did for that of the degrees, and let's assume that the length of this, and it has subtended some angles, say theta. It has subtended some angles, say theta. But if the angle that is subtended, the length of this angle, that is from here to here, if is the same as the length of the radius here, then we say that it has made 1 radian. That is, if this length here is equivalent, the length of this radian is of this radius here, if is equivalent to the angle that it has subtended, that from here to here, if this is r, and the length that it has moved, if is the measurement is also equal to r, if this and this is equal, if the length is also equal, then we are saying that it has made 1 radian. Now, if it didn't stop and it moves around the circle, then you know that the length of the circumference is what? 2 pi r. 2 pi r. So in terms of radians, you say 2 pi radians. 2 pi rad. That's what you have. So if it didn't stop here and it moved back to this point, in terms of degrees, say 360 degrees, but in terms of radians, being that it has moved around, it has moved around the circumference of a circle, we know that the length of the circumference of a circle is 2 pi radian. That's what we have. Now, you can also talk about this in terms of, you can also compare this with that of a degree. You can compare this with that of degree. Now, for that of degree, we said, for that of degree, we have said 2 pi rad is equivalent to, for degrees, we said is 360 degrees. That's what we said. Then meaning that just pi rad will give you half of this. If we divide this by 2, then dividing this by 2 is 180 degrees. 180 degrees. Pi radian will give you 180 degrees. What if we are interested in pi rad all over 2? Meaning this one again, all over 2, will give us 90 degrees. Will give us 90 degrees. What if we are interested in pi rad all over 4? Then this will give you 45 degrees. Because pi rad is equal to 180 degrees. So this divided by 4 will give you 45 degrees. What if we are interested in pi rad all over 3? This one is 180 divided by 3, which is about 60 degrees, and so on. We can also talk about it in terms of 3 pi all over 2. 3 pi radian all over 2, which is 270 degrees. So you can also relate radians and that of degrees. And you can convert things that are in radian to that of degrees, and also things that are in degrees to that of radian. Now, when you are talking about the movement, the measurement of angles, the direction that it moves matters a lot. The direction that it moves matters a lot. If this is a clock here, now a measurement that moves in clockwise are negative angles. Negative angles moves in this direction, whereas positive angles move in anti-clockwise direction. Now, when you talk about anti-clockwise direction, then you're talking about positive angles, whereas this clockwise direction movement is negative angles. Now, if that's true, then let's, can somebody sketch? Can we sketch? If that's true, then let's sketch. Let's sketch the following. The following angles, where one is 30 degrees minus pi all over 3 We have minus 390 degrees, 770 degrees, to pi. We can sketch these ones. Now, let me also use this medium to establish that I can also talk about angles that are greater than 360 degrees. When it comes to that, then it depends on the number of revolutions that it has made. That is, if this is the starting point, if it moves from here to here, we call it one revolution. Okay? Then it can continue, keep moving. Then it depends on the number of revolution. If you're interested in a fan, if your fan blade is at this point, and if you take that as the reference point, the fan blade rotating in this manner, coming back, fan doesn't stop once you turn it on. It will move, complete one revolution, it will come. So you can talk about several revolutions. So it depends on the number of revolutions that we're talking about. So what we try to say, when we're talking about angles can be more than 360 degrees. Now, if we want to sketch this, that of 30 degrees, as we said, we should sketch, this will sketch as, if this is the reference point, then you know that here to here is 90, here will be 45, then 30 will be somewhere here. 30 will be somewhere here. Now we are measuring it in this direction because it is positive. We have said that positive angles move in this direction. Positive direction, then negative direction. This to the clockwise is negative, so anti-clockwise is positive direction. So this one here will be 30 degrees. Now for this one, we have that pi all over 3 is 60 degrees. But 60 degrees is in negative direction because we have negative of it. So negative direction meaning that the sketching, assuming this is this reference point, the sketching will be in this direction. Knowing that here is from here to here will be 90, then 60 will be, say, maybe somewhere here. Negative 60 degrees, but we said negative pi all over 3. That's what we have. So the measurement, the direction of the measurement matters a lot. So the class can also do this. For this one, is more than one revolution. It's more than one revolution. So it will go past it, then pass again. Like this one will go for that of this. This one will go 360, then 930 again to it. So somewhere here. One complete revolution, then 90 again. So we talk about 390, negative 390 degrees for this. And in like manner, you can also measure those ones. And as I have said earlier, we can also talk about measurement, converting from one measuring unit to the other. We can measure from radians to degrees and from degrees to radians. Let me also give you a few examples that we may maybe test ourselves with. Then I can say, let's express 73.150 in rad. Then you can say express 0.6149 rad in degrees. In degrees, we can express from degree to radian and also from rad to degrees. These I will want the class to test ourselves with. Now, before I stop, let me quickly talk about trig ratios. Let me talk about trig ratios quickly. Trigonometric ratios, or you say trigonometric ratios. Now, what is it all about? Now, our interest here is to consider a right angle triangle. Now, in the other one, when I started, I talked about a complete revolution 360. Half of it is 180. Then, if we bisect that into four halves, then this one will be 90. Now, when an angle subtended is 90, this we can also call right angle. Right angle. And from here to here, it's has formed a triangle. So this is a right angle triangle. Now, I'm pleased to also let you know that any angle that is greater than 90 is called obtuse angle. Then any angle that is less than 90 is called acute angle. Any angle greater than 90 is called obtuse, whereas that of 90 is this. But when it's 90, we say this one is a right angle triangle. Now let's consider this vertex point A. Let's call this point here C, and let's call this one B. Now, if we assume that, let's consider an angle that is subtends at this vertex here, at the point B, then this, then we are saying that this side becomes the opposite of the angle. This side facing this angle theta is the opposite of it, whereas this lengthy side is called the hypotenuse, and this one is called the adjacent. So in terms of this A, you know that A is facing this way, so this you can call A. This one facing this you can call C. Then this one facing this way, so this we can call B. So this is what we have. Now we can talk about this angle in terms of sine, cosine, and in terms of cosine and the tangent. Now, those of you that are used to your SOHCAHTOA, the sine of this angle is simply opposite over hypotenuse. Opposite over hypotenuse. Opposite is the sine of that angle. Sine of that angle theta is opposite over hypotenuse, which is opposite is B, all over hypotenuse is C. That is what you have. Then the cos of this angle is adjacent over hypotenuse, whereas the adjacent here is A, adjacent all over hypotenuse, which is A all over C. And the tan of that angle is this over this. Opposite over adjacent, that's what we have. Opposite, which is B all over adjacent. B all over, opposite all over adjacent, which is B all over A. That is what you have. Now, this tan here, we can also rewrite in terms of sine and cos. How do I mean? If you make A here the subject and you make B the subject, if you make B the subject, you are going to have B will be equal to C sine theta. And if you make A the subject, you have C cos theta. C cos theta. So B over A, as we have here for that of tan, B over A therefore gives you C sine theta all over C cos theta. This and this is off, and you have sine theta all over cos theta. Sine theta all over cos theta. So tan, in a nutshell, can also be written as sine theta all over cos theta. Now, we have three of them. One is sine, one is cos, and the other one is tangent. Then we can also talk about the reciprocals of these ratios. Reciprocals of these ratios. If we are interested in the reciprocal of these ratios, then of these trig ratios, then we are saying that maybe 1 all over cos theta, then 1 all over sine theta, then 1 all over tan theta. 1 all over cos theta is the same thing as sec theta, sec theta. 1 all over sine theta is cosec theta, and 1 all over tan theta is the same thing as 1 all over, because we have established that tan is the same thing as sine theta all over cos theta. This you have as cos theta all over sine theta equal to cot theta. That's what we have. 1 over tan theta is equal to cot theta. So we have sine theta, cos theta, tan theta, then the reciprocal of the ratios is sec, cosec, and cot. Now these 6 functions that we have are called the fundamental trig ratios. They are called the fundamental trig ratios, where the denominators here are not equal to 0, and that is valid for the interval. The theta here is valid for 0 less than equal to theta less than equal to 2 pi. It's valid within that range. We are going to stop here. These 6 functions that we have will enable us to go through some mathematical joggings as we continue to consider new and other areas of trig in our next class. Thank you and God bless.